I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see the introduction about ensemble learning. First, you should know why we should study this ensemble learning. This ensemble learning is a powerful machine learning technique that combines multiple individual models known as Bayes learners to create a stronger, more accurate predictive model. The idea is that by aggregating the predictions of several models, the ensemble can reduce errors and improve generalization, making it more robust than any single model. This approach is particularly effective in overcoming the limitations of individual learners, such as overfitting or underfitting, and can handle both classification and regression tasks. Common ensemble methods include bagging, boosting, and stacking, each utilizing different strategies to combine the model's outputs and enhance performance. We'll see one by one. First, we should know what is ensemble learning. The ensemble learning is a machine learning strategy that combines predictions from multiple individual models. So, this is very, very important. Multiple individual models. It combines the predictions from multiple individual models, also known as Bayes learners, to form a more accurate and reliable final predictions. Instead of relying strong learners, we can say that instead of relying on a single model that may have limitations, ensemble learning integrates the strengths of several models to produce better results. This method is commonly used in scenarios involving classifications or regression where performance and robustness are crucial. And why we have to use this ensemble learning? Ensemble techniques are widely used because they significantly increase the accuracy and prediction by minimizing the individual model weaknesses. They help reduce overfitting, which occurs when a model learns the training data too well but fails to generalize new data. Overfitting means fails to. So they help reduce the which occurs when a model learns training data too well, fails to generalize the new data. Fails to generalize. That is known as new data. By combining various models, ensemble methods balance the trade off between bias, that is, error due to assumption, and variance, error due to sensitivity to data fluctuations, resulting in more stable and reliable performance. Additionally, they are more robust, these ensemble learning, to noise and making them effective in real world applications where data may be imperfect. And the common ensemble techniques what we are using it, there are several widely used ensemble techniques in machine learning, the namely bagging, and the another name of the bagging we can call it as bootstrap aggregating. And this bagging involves training multiple models on different random subsets of the data and combining their predictions, which helps reduce variance. So this is known as the bagging. One more time I'll tell you. Bagging involves training multiple. This involves training multiple models on different random subsets of the data and combining their predictions, which helps reduce variance. Next, boosting. The name itself, we can say that. On the other hand, trains models sequentially where each new model tries to correct the errors of the previous ones, effectively reducing bias. Next one is the staking. The stacking, not staking, the stack. Stacking, which we have studied in the first unit. Stacking involves training a meta model to combine the predictions of several base models, learning which one perform best in specific scenarios. Lastly, voting classifiers combine the outputs of multiple models through majority voting, that is for classification, or averaging for regression, providing a simple yet effective ensemble method. So there are, what are all the techniques? Bagging, boosting, and stacking. Next, voting classifiers. Next, we should know what is the supervised learning or the key differences from the supervised learning. The main difference between supervised and unsupervised learning lies in the presence of what? Presence of labels. Supervised learning required labeled data where each input has a corresponding known output, enabling the model to learn the mapping between them. In contrast, in unsupervised learning deals with unlabeled data and focuses on identifying structure or groupings structures in this algorithm. Unsupervised, while supervised learning aims to make predictions, unsupervised learning is more about pattern discovery and summarization of data. This makes unsupervised learning suitable for tasks like this unsupervised learning, which will be very much useful for the task like clustering. Okay, this makes the unsupervised and anomaly detection. Anomaly reduction and dimensionality reduction. In these cases, we are using dimensionality, dimensionality, dimensionality reduction. We are using this unsupervised learning. Next, these are all the key differences between the supervised learning from the unsupervised. We are using that is data labels. We are using it. Yes, required, not required. And output type here compulsory will be able to know. Here it is unknown or hidden. In the supervised learning, what is the main goal? Prediction. And unsupervised learning, the main goal is to discover, that is pattern, to discover the patterns. So next, the popular unsupervised learning algorithms are, among the most common unsupervised learning algorithm is k-mean clustering. Clustering techniques that partitions the data into specified number of groups based on similarity. In this, based on the similarity, it will be grouping the data. This hierarchical clustering builds a tree of clusters by progressively merging or splitting them based on distance metering. Here, merging or this will do merging or splitting based on what? Merging or splitting based on the distance metrics. DB scan, that is this DB scan, we can call it as density. DB scan means density, that is density based spatial clustering. What do you mean by spatial clustering of applications with the noise? This detects the clusters of varying shapes and sizes, including noise patterns. So this will it segregate the data sets of varying shapes and sizes, including the noise patterns. For dimensionality reductions, we are using the very important algorithm called principal component analysis. This will transform high dimensional data into low dimensional data. form, that is low dimensional form, while preserving as much as variance as possible. And another method, TSNE, it is used for visualizing complex data. It is used to visualize the complex data. How? By mapping it to two or three dimensions in a way that maintains relative similarities. Next, the applications of ensemble learnings are ensemble learning is widely applied in industries that demand high accuracy and reliability, such as credit scoring, where financial risk is assessed. A medical diagnosis, next application, where accuracy can impact lives, and spam detection in email systems. On the other hand, unsupervised learning excels in scenarios where labels are unavailable. It is used for it is no it is used in customer segmentation to identify distinct groups of consumers, and anomaly detection to flag unusual behavior such as fraud and market basket analysis to find associations between items frequently purchased together. Next, but that is also it is used in the there is market basket analysis. Both techniques play a crucial roles in making data driven decisions. Okay, coming into the summary. In summary, ensemble learning enhances the machine learning model performances by integrating means combining multiple models to create more robust and accurate systems. It is especially effective in reducing errors caused by individual model limitations. Unsupervised learning, on the other hand, allows machines to discover patterns and grouping in data without the need for labeled outputs. These techniques are widely used across industries for tasks ranging from predictions to pattern recognition and data exploration, making them essential tool in modern machine learning process. So that's all about that we have learned this ensemble learning introduction about or basics about ensemble learning. The remaining things we'll discuss in the next class. Thank you.